Hello everyone, in this video we're going to be talking about how to calculate speed, and we'll define what speed is, and then we're going to look at speed distance time graphs. Two variants on these, so we'll do a distance time graph and a speed time graph, and we'll explain what the shapes of the graph mean and how we can calculate a speed value actually using one of them. So let's think of this kind of scenario we've got here. Let's imagine here's a track. So imagine this is an athletics ground, not the best sketch, but so we've got the track here, we've got a bit of grass on the side. Here we've got our competitor that's running in this direction, and they're running towards, let's put in a finish line. They're going to have to cross, just a very rough picture there. So they're running a sprint and they're going to cross the finish line. Let's think about the speed of that runner. So that runner is going to be running a certain distance. They're going to go from one point to another and give us a distance. And they're going to run that certain distance in a particular time. And this is how we work out speed. Speed is distance divided by time. So the speed is defined as sort of the amount of distance covered per unit time, the amount of distance you cover in a given time period. So units for distance, well, distance could be in centimetres, metres, millimetres, kilometres, but we're going to use metres as our example here. Time could be in seconds, minutes, hours, but we'll take seconds as our units in this race. So the units for speed would reflect our units for distance and time. So this would be meters per second, because we're looking at the amount of meters run in every unit time, in every second. That could also be written as meters and S with a -1 above it. The -1 represents that per, that line, or if you like. So ms -1 is the same as meters m with a slash and then an s. So that's what our speed is, our distance divided by our time. And you might have seen in school this particular triangle. I know certain people find this useful. This line here represents, in fact I'll draw it in red, that's a divide by line, and this is a multiply. And they put speed here, distance here, and times here. And this little nifty triangle can be used, whichever one you want. You imagine that you cover up with your finger and it will show you how to work out what you need. So if we covered speed, if we imagine covering speed, that would leave us with d divided by t, distance divided by time. So there's a nice little triangle we could use. So if you wanted time, that would be d divided by s. Or if you wanted the distance, that would s times t. So we'll just put here as a sort of extension. Speed is distance divided by time. If you rearrange the equation, distance would come out as times multiplied by speed. And equally, time would be distance divided by speed. So that's just how you work out speed. And you may be asked to do a conversion. So let's pretend in this example that I ran, I'm very unlikely to run a speed of this, but let's say that in that 100-metre race, that race at the top, that's me, let's say we ran 100 metres. So the distance from A to B to that finish line was 100 metres, and let's say I did that in 10 seconds. Then my speed would be 100 divided by 10, which is 10 meters per second. So that's my speed, 10 meters per second. Now you may get asked to convert. So for example, 10 meters per second, if I could do 10 meters in every second, in a minute I would be able to do 60 lots of that, because there are 60 seconds in a minute. So 10 meters per second would be the same as saying 600 meters per minute. Or if I were to convert it into kilometres per second, 10 metres is the same as saying 0.01 kilometres. Kilo means 1,000. So 10 metres per second is the same as saying 0.01 kilometres per second. You may get asked to convert between units, or you may get asked just to calculate a speed given a set distance and time. So that's how you work out speed. Let's look at distance time graphs and how you can work out speed from those. So we'll shrink the screen down just a little bit here. I'm going to draw a very basic distance time graph. So let's say time here is in minutes. Let's say we've got a distance up the y-axis, and our distance here will be in meters. Let's put some unit. Let's say here's 1, 2, 3, 4, 5. Let's say here is 5, 10, 15, 20. Let's just go to 20 on there. Let's put in 25. There. Now I'm going to draw so it's a very rough sketch of a graph, but we're going to analyse this distance time graph and show how we can work out a speed from it. So imagine in this scenario that I'm in a car and I'm going from point A to B in my car. Here is A, and here, let's say, is point B. So as time goes on the x-axis, we can see distance on the y. So let's look at this first phase here. We'll call this 1, 2, 3, and 4, if we split the graph into 4 parts. At 1, we can see that as time goes on, our distance is increasing. So number 1, I would be moving away from point A. That's what's happening at number 1, I'm moving. At point 2, if you notice that as time goes on, my distance hasn't changed. This flat line means that my distance isn't going up or down. So that would be where I have stopped. At 3, we can see that the distance is now changing, so I've moved. And then at 4, so we've reached our point B, and then we can see this line coming down on the graph. So this one here, at phase 4, that would imply that we're moving almost back to our original, to point A. So I've taken a journey from A to B, and now I'm coming back home. I'm coming back to A because the graph is now giving a sort of distance back to our point of origin, to 0. So let's think about some common questions you might get asked in this scenario. You might get asked, how long did the car stop for? So if we look at phase 2 where we stopped, all you would have to do, put one line in there, one line in there. Now it's not the clearest of scales, I know, but what you'd essentially have to do is just look at the x-axis and then work out the time period that flat line represents. So we can see our red lines that we've drawn down here start at 2 and end at 3. So we've stopped for a period of 1 minute. Now you may get asked to work out speed, and that's what we're going to do on this particular graph here. Speed, we said, was distance divided by time. So what you can do is use this sort of triangle method, if you like, where we plot out a set distance in a given time. So if you look at this region here, now in a shaded green, I've just created a sort of triangle here where we've got 3 sides. One of the sides is our time axis here, and one of them is our distance. And we just have to look at where those values come to be able to give a value for a distance and a time to get a speed. So let's think this through. I want to know the speed that I was going at in phase 1, where my distance is changing, where I'm actually moving. So that would be distance divided by time. My distance, so if I look at this particular scale that I've drawn, I've started at 0. If I continue across here, I can see that this would hit 15. So my distance moved is 15 meters. I've done that in a time of, well, if you look at this green triangle that I've shaded, we can see that it goes from 0 to 2 minutes on the time. So I've done that 15 meters in 2 minutes. So that would give me a speed of 7.5 meters per minute. So using a distance and time graph, all I have to do is find an area where I'm moving. So I could have used this one, or if I do it in purple, I could have chosen this point here. And using this, read off values for my distance and for my time and apply the formula. So that's how you use a distance time graph to work out the speed, using the sort of triangle method. I want to finish this video just by highlighting something about a SpeedTime graph. So I'm just going to reduce the size of the whole screen for a moment, because I think it's important to note this fundamental difference. In fact, draw this black here. Now I'm going to have time on the bottom still, and we'll keep it in minutes. But this time, instead of distance, I'm going to put speed on the y-axis. We'll have speed in meters per minute again. And just for the sake of argument, I'm going to draw the same shape graph, because I want to explain something very key on this particular graph. We'll have the same phases, 1, 2, 3, 4. Now at 1, on the distance time graph, that would imply that we are moving, because as time goes on, the distance is changing. On a speed time graph, where we have that rise, so in our first phase on the graph, that means that over time, the value for our speed is going up. So at 1, we're actually accelerating. Where we have this flat line at 2, this doesn't mean that we've stopped. It means that the speed that we're at, the speed that we've reached, isn't changing. So we're at constant speed. So that's what number 2 means. And I wanted to highlight the difference between the flat line on this graph and the graph of a distance time set of data. On the distance time graph, a flat line means stopped, whereas a flat line on a speed time graph means constant speed. 3, you might be able to appreciate, is an accelerating phase, again, because our speed is rising as our time does. And 4 is a bit different, because our speed is now coming down. Because this line is coming back to our original, this means that the speed is reducing. So 4, what we have is a deceleration. So we have a deceleration at 4. So I just wanted to show the speed time graph to show really and highlight the difference between the flat lines that you get and what they mean. And the purpose of this video is to show how to calculate speed. Speed is distance divided by time. And if you're stuck, I'd recommend using this nifty little triangle here to help remember how to work out speed. And you can also use it to work out distance and also to work out time, just by rearranging the same equation. Okay, hope all that helps.